And so I'm going to have us write this out in other words because I know that might have been a little bit weird and confusing. It's this next bullet of theory of a confidence interval. If we select many different samples of the same size from the same population and we constructed the corresponding confidence intervals, blank percent of them would contain the parameter. It's a theoretical idea of if I were to do it a bunch of times, that percentage of the time it would work. Okay. Notice that my confidence is in the procedure, not in the interval itself. And you say, well, I don't even know what you're talking about anymore because this is kind of a weird idea. What I want to make sure we understand is that my confidence, this 95%, 90%, 99%, whatever the confidence level is that we talked about previously, the confidence that I have comes in the procedure of what if I were to do this a bunch of times. It's not in my one interval. What I mean by that is my one interval might be good, it might be bad. I really don't know and I can't assess it. Why is that? Because the underlying math that we're not going to go into the details of the why because it gets really gory, but the underlying math just says most of the time these things work. And most is the confidence level. That's what we mean by most, whatever the confidence level is, 80%, 90% doesn't matter, right? But that's the most of the time. Most of the time this works, but occasionally it doesn't. I have no faith in my one interval because I might have got a weird one. Okay, my one interval might be weird. So my confidence is not in my interval, it's in the procedure. Okay, it's like saying the probability that I start my car and it works is 95%, 99%, whatever. Your confidence isn't necessarily, hey, I'm going to go out today and I think it's going to work today, because you don't really know what's going to happen today. What your confidence in is, in general, most of the time when I go outside and start my car, most of the time it works. Your confidence is not in today, insert whatever today's date is. Your confidence is in the overall, most of the time when I go outside and start my car, most of the time it works. Okay, and so it seems like nitpicking, but I want to make sure we understand that our confidence is in the process, not in the actual interval. And so we have a specific way we want to word this and a specific way we don't want to word it. And that's what I want to talk about next. The specific way we want to word this is we are blank percent confident that the interval from blank to blank, we're going to put the lower bound and upper bound of the interval in those second blanks, contains, and I put in brackets here, the parameter of interest. We're going to write out the parameter of interest in words. And we'll talk more about that later. And the reason why this is an okay phrase to use is that in statistics, this word confident is a very charged word. And so I want to dive down a little rabbit hole with you here. And this is the idea that in the English language, and in every language, we have certain words that may not have certain meanings to everybody, but they do to certain people. Certain words are charged to certain people. And it's not even words. Sometimes it's the way that we present things. Sometimes it's the look on our faces. Sometimes it's the emoji that we use or don't use when we're sending a text, right? It's including a period at the end of a text or not. There are these things in communication where when you do or don't do certain things, certain people know what you're trying to say, even if you didn't say it, right? And if you just stop and think about it, you know that with anybody that you have a relationship with, romantic or not, doesn't even matter. You know that there are certain things that that person can do or you can do to that person that say something without actually saying those words. That's how communication works. And in statistics, this word confident is one of those words. When we say we are blank percent confident, it means we are blank percent confident in the process of repeated sampling, right? It's like if that's what's implied. Because I want to make sure we understand that we are confident in this repeated sampling paradigm. We are not confident in our one interval. Again, our one interval might suck. We hope it doesn't. We'll kind of come back to that later. Okay, but we don't know anything about the one interval that we got. It might be good, it might be bad. What we are confident in is this process of if we were to do it a bunch of times, the math says most of the time it's going to work. So our probability is assigned to the process of repeated sampling, not to the individual interval. So the incorrect way to say this is that there is a blank percent probability that the parameter of interest will fall between blank and blank, because now this sentence more so implies that we know something about our one interval, and I want to make sure that we understand that we don't know anything about our one interval. It might have captured, it might have not. Okay, we have to keep that in the back of our mind. So the problem with this phrasing, and the reason why this is a phrasing that we don't use, is because when we say there's a blank percent probability that we've captured the parameter of interest, it implies that we know something about our interval and we don't. And again, in the language of statistics, by using the word confident, we are telling other people who also speak this language that we're not talking about our one interval, we're talking about the overall process. And just to beat this point home, I have this little thing written out here. At any specific point, a population has a fixed and constant value of p. Now, the whole point of this is that we don't know what p is, right? If we knew what p is, we wouldn't be here. The idea is p exists, we just don't know what it is. Okay, and a confidence interval that we construct either includes it or it does not. So I want to make sure we understand that when we say what is the probability that we've captured the parameter in our interval that we just made or not, the probability is 1 or 0, right? And I want you to, if you have to pause and think this through, that's totally okay. If we construct the interval, let's go back to that example I made where I said that hypothetically we made a confidence interval and p is between 30% and 60%. P exists. I don't know what it is, but I either got it or I didn't. So I would say that the probability that I captured it in my one interval is 0 or 1. I either got it or I didn't, right? And so continuing on, if the coin's just been flipped, it's incorrect to say there's a probability of 0.5 that the coin is heads. The probability of 0.5 is not about the one flip, right? The one flip was heads or it was tails. The 0.5 has nothing to do with one flip. It has to do with a large number of flips, an infinite number of flips, right? It's the idea of think about what the denominator is. When I flip a coin one time, my denominator is 1. It's either 0 over 1 or 1 over 1, depending on how I define success, right? So what we're talking about is the denominator the infinite number of times I would flip a coin or the one time I would flip a coin? When I flip a coin one time, it's not a probability of 0.5. It either is or it isn't. There's no probability. I either got it or I didn't. And that's the same with the confidence interval. We're saying that if I talk about my one interval, I either got it or I didn't. So you can't say there's a 95% chance that p falls between the values, because between those two values, p either is or it isn't. There is no maybe. All right. P either is or is not in your interval. So what the probability is, however, is if I were to make a denominator of what if I did this a bunch of times. Now remember, we're not going to do it a bunch of times. All right, so we don't have to, it's theoretical. It's all theoretical. We're not going to go out and do the interval a bunch of times, but we're saying if I were to do it a bunch of times, that's the percentage of the time it would work. My one interval either worked or it didn't. Right, the probability that my interval, that one interval that I build, and we'll build some later on, the probability of capturing the parameter in that one interval is 0 or 1. We either got it or we didn't. We're either right or we're wrong on that one interval. So the probability has nothing to do with my one interval. It has to do with this long run, how many times did it work? And that's what I'm going to finish this off with here, hopefully hammering the point home. Confidence level of 95% tells us the process we're using in the long run will result in limits that contain the truth 95% of the time.